So the first thing we have to do is find the inverses of A and B. What do we need to do first on A?
Switch X and Y.
Switch X and Y, right? We know that f of X is just another, it's the function notation for Y. So I'm going to immediately switch these two. And it becomes X equals log base 2 of 2 times Y. Now what do I have to do?
Exponential 2. The log is the letter next to it.
Yes, you need to, so first question is the log term by itself? Yes. So I can immediately try to get rid of the log. How do you get rid of a log? You do the opposite operation, which is exponential, meaning you have to exponentiate both sides. Or in other words, make everything that is here an exponent of what base? 2. So I put a big 2 as the base on both sides. So on this left-hand side, I have 2 raised to the power of x is equal to, what happens on the right-hand side?
Cancels out.
Yes, 2 raised to log base 2 cancels, and you're left with just 2y. Not in an exponent anymore. I'm sorry, not being logged anymore. Now what? Yes, we need to get the 2 off of the y still, so I divide by 2. Here the 2's cancel. Do the 2's cancel here? No. Why not? The numerator 2 has an exponent on it. We don't know what that exponent is yet, right? We don't have a value for x, so you cannot just willy-nilly be canceling the base. If there was another 2 in front of it, then you could cancel those 2's. But there isn't, so we can't. So my answer is f -1 of x, right? The inverse notation of the function. The inverse of f of x is equal to 2 raised to the x power over 2. That's my answer. Any questions on finding that inverse? Yes.
If x happens to have already 5 minus x, will we just have to raise it to
Then that whole thing, 5 minus x, would be in the exponent.
okay.
All right, so now we do have to find the domain and range. Now, a lot of you guys were asking me, how do you do this without a calculator? Because, of course, you could plug this into y equals and see what the graph looks like. But I think it is sometimes hard to look at a graph and understand exactly where your asymptotes are, right? So it's better to understand what's actually happening here. In order to know the domain and range of this function, you kind of have to have an idea of what the original parent function looks like. So what type of function is our inverse? It's an exponential. Now, one of the defining characteristics of an exponential is that asymptote, right? Exponential graphs, do they have vertical asymptotes or horizontal asymptotes? Horizontal, yes. So if I'm drawing a little graph, if I'm sketching a little graph, I do know that I have a horizontal asymptote. Now, having that horizontal asymptote, what is the only translation that will move your asymptote? Up, down. Right? If I move left and right, is that line really actually moving anywhere? No. But if I do move up or down, is the asymptote moving? Yes, it is. So we ask ourselves, does this function have an up and down movement?
No.
No. That would be a number after, like a +2, after, at the end of the function. But we don't. So where is the asymptote actually? 0. It remains at 0. We can't really see that. I'm going to do like dashed lines. Even though, how are you supposed to write an asymptote on a graph? Dashed. Dashed. Make sure you're doing that on your quiz. I need to see those asymptotes. Now, there's our asymptote, and our graph is somewhat shaped like this. What is our domain? All real numbers. Guess what? Exponential will always have a domain of all real numbers. Always, always, always. Will not change. The range, however, will change based on your asymptote. What is the lowest x value? 0. Are you touching 0? No, that's where your asymptote is. What's your max? Infinity. So what do I say here is my range? Not greater than or equal to, so it's just a greater than symbol. Y is greater than 0. Any questions here?
So that like bottom two literally doesn't affect it at all?
What?
So that like bottom two, like the...
This
it means it has
is
literally no-
technically a vertical compression by a half.
Okay.
Another way I could have written this was 1/2 of times 2 raised to the x power. So it's a vertical compression by a half, which we know stretches and compressions do not affect domain and range. Only translations affect domain and range.
This might be a long question for you, but when you were giving an
So in interval notation, this would have been negative infinity to infinity. And in interval notation, are we touching 0? So we put a what next to the 0? Parenthesis up to infinity. Thank you.
Graphing from the asymptote is supposed to go. Can you solve
Yes.
that?
Yes, after this warm up, because Ari has already asked me to go over graphing, so I will graph something actually, but I don't want to do it here. All right, so next one, part B. How do we start finding the inverse here? You switch x and y, so x comes out front, and y is with the 4 in the exponent now. So, is my exponential term by itself? Yes. This is the exponential term. It's the term with the exponent. The term with the variable in the exponent. It is by itself. So I can immediately deal with the exponential term. Yes. In order to get a variable out of an exponent, you have to do the opposite operation, which is logging. So I take log of the same base of both sides. What is my base? So I do log base 3, log base 3. On this left-hand side, it just remains log base 3 of x. What happens on the right-hand side? The log base 3 of 3 cancels, and that exponent is now no longer an exponent, and it's just 4y. Yes, Jess?
So it would not have been alone if there was like a plus.
So if there had just been a plus 2, then there just would have been a plus 2 here.
So would you have to switch it together, like bring it together?
Now you would, yes.
Okay. Yeah, I'm sorry for these questions. I know they're kind of dumb.
Because it was supposed to be myself first.
I had the 2 here. It's still in the exponent. So see how it's still in the exponent? That means after I log, that's when I would subtract the 2 over.
So if it was at like the 3 level, then you do it first.
Exactly. If it was like this on the bases level, then you would subtract 3 over first. Yes, Emma.
How do you know like whenever you bring over the number from the right side to the left side to make the number the exponent? Does that make any sense? I'm sorry.
What? Say it again. No, say it again. I just wasn't following. Say it again.
Whenever you take the number from the right side, okay, yeah, and you move it over to the left side,
Yes.
how do you know when the number on the left side is already there? Goes to like
Oh, it depends on when you are applying the log. So if you move the 2 over first and then log both sides, that means that your 2 is also being logged. Does that make sense? Is that what you're asking?
Yeah, but like I don't understand it.
Okay. So if we had this, the 2 is not in the exponent. We have to subtract it over first, right? So it'd be x minus 2 is equal to 3 raised to 4x. Now we log both sides. So it'd be log base 3 of x minus 2. That minus 2 is with the log because I'm logging the entire left-hand side. Okay, so that equal to 3 raised to 4x. It is different, however, if your 2 is with the exponent. Because now, immediately, I log both sides. Now I subtract 2 over. The 2 is not being logged. It is after the log. Yes. Because it's not being logged. Yes. Does that make sense?
So you put a parenthesis around the x, you do that when whatever number is being logged?
Being logged, yes. So here I put parentheses around x minus 2 because all of that is logged. And here I only put a parenthesis around the x, showing that only x is logged.
When you say something's being logged, it's being multiplied, or
It looks like multiplication, but remember, log is an operation, just like multiplication is an operation. So you're applying the operation log to x. So that's why I say it's being logged, because it's an operation. If you want, you can think of multiplication, as long as you know you can't just divide to get it off. All right, let me finish up this problem here. Yes. Divide both sides by 4, and then change y out for Taryn. Change y out for, what was our problem? H. So you do the inverse notation for h. Here you go. And that's our answer. Now, we do need to know, for this problem, to find our domain and range, what the parent function looks like. So, this is a log. What type of asymptote does it have? Vertical or horizontal? Vertical. Now, it having a vertical asymptote means only left and right movements will move it. So does this function have a left and right movement? No. So where is your asymptote? It's still on 0. It's still right there. So my function looks something like this. Now, what is my domain? Not for logs. Domain is affected by the asymptote. What is my lowest x value? So x is always greater than 0. What is my range of log? Logs will always have a range of all real numbers. We learned last class that these are inverse functions. Inverse functions always have flipped domains and ranges. So exponential, domain is all real numbers. Log, range is all real numbers. Always. All right. It's okay. It's all right. Breathe. Here we go. I did change this warm-up because I noticed on your quiz you do have a problem that is written in function notation, which is what this is. All that this means is that f of x equals 4x is your original function, and then what is happening to the second function? What do you notice? The x, is it just x now? What has it been replaced with? And this means in this function, wherever you see x, you are replacing it with everything that is inside the parentheses after the f. So this becomes 4 raised to the power of 3 times x plus 2. And then after the function, outside of the parentheses, we have a -4. That means after 4 raised to the x power, we put a -4. Yes, Dario. Yes. Does that make sense? All we did. So let me give another little example.
Yeah, you just have to write it, or then you have to like.
I don't like that.
No, I guess not necessarily.
Do we solve that? Like,
How would you rewrite this one?
so 2 to the right raised to the power of x minus 2. And then plus 2.
Good.
I got it.
Yeah.
Johnson can get it.
Look, if I could get it, anyone.
So knowing this, what does the 3 do? Oh, what's up, Preeti?
Oh wait, me? I said fine. I thought you told me that. I was like, oh. Can you get it up from 2 real quick? I just want to see it.
It's this right here, Preeti. And this.
So, my son will
What does the 3 do? It's a horizontal compression by a third.
Yeah, I was right.
What does the 2 do?
Oh, it goes left to left.
Translated left 2. And what does the -4 do?
Down 4.
Translate down 4. No, the 4 is your base. It isn't a transformation. If you had a 2 in front, that's your A. If you had a 2 in front of your F, that would be what you put in front, and it's your A value.
And that's the stretching.
No. You're basically what you're doing here. Okay. What you're doing here is you're taking what f of x is equal to, 4x, right? And instead of writing 4x, you are taking everything that your new f of x is. How do I explain this differently? Yeah, you're just substituting in for x. So, Okay, no, I thought I had it.
It's like you can have the F of
It's like the
No, it's your base.
It's a C.
It acts like a slope. It looks like a slope on a graph, but we call it the base.
So would it be 4 or 1 or 1?
It's not a transformation. You don't say it. Oh, it's on this exponential. It's up 4 over 1. All right, listen. Shh. I keep losing it. I'm so sorry. Okay. No. Like, all you have to know is that everything that is inside after your f is replacing x. Because that's what was in our original equation, right? Just an x. But it has now been substituted for 3x plus 2 instead. So now,
Something similar to this.
yes, we have. This is just function notation. It's just like compositions. Remember compositions?
How to do that? I just don't put the A part because I feel like I'm gonna accidentally record A instead of base.
The A part is just the vertical stretch and compression part, right? Yeah. The A is just
That makes sense.
yeah. A is just a vertical stretch and compression.
Yes.
That makes sense.
So I think just the best one I just told you, I'll be understanding.
Yeah,